Hello and welcome to a short demo of Solita's Agile Data Engine. In this video, we will walk you through the basics of the software service and show you how it works in practice. So let's get started. Agile Data Engine is a software service developed by Solita. We call it a DataOps platform for cloud data warehouses. It is used for designing, deploying, and running the cloud-based data warehouses. It covers the functionalities of ETL or ELT tools and data modeling software and adds other capabilities in the mix. If you are wondering what DataOps means, to put it very simply, it is about automating the development and operations processes for data solutions. Automating these processes in the way that is familiar from the software application development. So, with Agile Data Engine, we have brought the DevOps capabilities into the data warehousing. So, Agile Data Engine does the data modeling and ELT development, but the real reason behind why we developed it is that we wanted to solve certain major challenges in a modern data platform development. First, how to create a cloud-based analytical data capability quickly and at the same time in a managed way, and with cloud-native technology. So no compromises between shall I do it quickly or do it well in a future-proof manner. Secondly, we are making the data warehouse work truly agile. Agile methods and mindset are not enough. Tools need to support and enable the incremental and iterative data warehouse development. Then we wanted to ensure that the data warehouse supports the operational needs of the business by enabling the data to be refreshed continuously in business real time. And finally, being future-proof means also that you will not be dependent on one data hero or heroette. I'm sure many of you have seen those data warehouses that are full of spaghetti code and there's only this one person who can navigate the massive manually drawn data flow and make changes to it. The secret sauce that enables all of these is the use of metadata in Agile Data Engine. Agile Data Engine introduces a new kind of architecture for cloud data warehousing. We call it a shared design multi-environment architecture. Both data models and loads are developed and operated with the mutual web-based design experience, and everything is based on metadata. ADE Designer has, for example, a powerful data lineage view which you can use for evaluating the impact of changes or getting the audit trail of where the certain data is coming from. The heart of Agile Data Engine and the key enabler of the DataOps approach is the out-of-the-box continuous deployment pipeline that enables iterative value creation. It, for example, handles the database schema changes in the target database platform automatically and also generates load workflows automatically, again based on metadata. Agile Data Engine also handles the orchestration and operations of the data warehouse loads. It utilizes the power and elasticity of a cloud database platform of your choice. You can even add data quality tests as part of your data workflows and continuously monitor the quality of incoming data. Agile Data Engine has three main software modules: Designer, Deployment Management, and Runtime. One essential module of Agile Data Engine is the Designer. This is where you will model your data warehouse data models and loads and workflows. This means defining all the tables and views, mapping their dependencies, and creating loads and schedules. In other words, in the Designer, you generate all the metadata that is required to build and load your data warehouse. Next to the designer, you'll have the deployment management and runtime environments. Once you commit your changes in Designer, they are taken in the commit repository, and then in the deployment management, you can decide in which runtime environments you wish to deploy changes to. Usually, you'll have runtime environments for at least development, testing, and production purposes based on the metadata you created in the Designer and the current state in the target databases. Code can then be generated to be run in your runtime environments. This includes changes to the target database objects, such as creation of new tables and altering of existing tables, and orchestration of your workflows with dependency and concurrency control. With Agile Data Engine, we enable a culture change in data warehousing by enabling iterative and incremental value creation, enabling you to be agile when business requirements and source data changes, and building a resilient and scalable data foundation. In the upcoming demo part, we will show some of the basic functionalities of Agile Data Engine. We will use a very simple and typical data warehouse architecture where we have a 3-tier data warehouse with staging area, data vault area, and publish area. Agile Data Engine does not force you to use this kind of layer architecture, but this is quite typical and works in practice very well. The biggest automation benefits from Agile Data Engine come when using the data vault methodology, but it is not required. Before starting the demo, it is good to introduce key metadata concepts of Agile Data Engine so it is easier to follow the demo. Package. A package is a single metadata module that includes a number of entities and their metadata. A package enables the modularization of the data warehouse content, data models and loads, into manageable and deployable pieces. This helps to achieve agility with truly incremental and iterative development. Package is the unit of commit and deployment. Then entity. Entity is the core metadata object in Agile Data Engine. Entity refers to data warehouse tables, views, or informational metadata objects. Building a data warehouse in Agile Data Engine is based on entities. Most of the metadata definitions belong to entity. Each entity has metadata that provides information about the entity itself. The metadata of an entity includes name, description, attributes, keys, physical options, load definitions, test definitions, and permissions. Workflow. Workflow defines how the data is loaded in runtime. The entities are connected via mappings that describe their dependencies. This is called data lineage. Entity loads with the same schedule are included in the same data workflow. Workflows are generated dynamically based on dependency and schedule metadata. Entity and load can be included in multiple workflows.
Now it's time to see all of this in practice, so let's start the demo. Okay, let's start this demo by talking about the designer. So once you log in, you will see this front page with a list of packages, and then on the right side you'll have the ability to create new packages, import them, import entities into those packages, and so on. And you'll also have a list of your environments. So in this demo case, we have the design environment, and then we have 2 runtime environments called the QA and the QA test. Let's look at the packages first. So if we filter this list to the demo setup, we have a package for staging, data vault, publish, and then some reference data and weather data. And if we look into one of these packages, we will see that they contain entities, which in this case are tables and views. The package also has some kind of metadata like descriptions and when it's created and so on. And when you're going to do some changes and commit them to your runtime environments, you do that on the package level. So the package is the unit of commit. The project has the ability to choose how they want to package their entities, but as you do the commits on the package level, it's good to keep the packages at quite a small size so that there can be multiple developers working at the same time and they will not be blocking each other's commits. Looking at the other options within the package, you have the Actions tab, which allows you to export the package. Now, this generates a JSON document which contains all the entities and their loads and attributes and everything related to this package, basically everything that it includes. So all of this is also exportable if needed. You can also export the SQL codes only. Then in the package dependencies, you see how it's dependent on other packages and which packages depend on this package in question. So since this is the data vault package, which is in the data warehousing layer, before that we have the staging package. So all the data from the source is loaded to the staging first, and then from the staging package to the data vault package. And from the data vault, we will load the publish layer. So there are a couple of packages that depend on this data vault package. Then let's go into one of the entities. Let's pick, for example, this hub rate code. So this opens the entity view, and then on the summary tab, you'll see basic information about the entity. For example, the type of it, this is a hub. And then you have things like the physical type. You could have a view or a metadata only entity. And you have the schema and also a description. And these descriptions will also be written to the target database for the table as table comments. Then you get a list of the attributes within this entity. So all the attributes and their data types and so on. And also these can have descriptions and such. Then some other things that you can do in the entities, you can add keys like primary keys, foreign key references. You can set entity permissions. So if you have some corresponding roles in the target database, you can select them here, and then once the entity is deployed into your runtime environment, those roles, the entity will be granted to those roles with the privileges that you have chosen. And in the loads tab, you see the incoming loads into this entity and the outgoing loads. Next, let's look at the data model and data lineage views. So let's go into the data vault package. Click on the top right corner and look at this model that we have here. So in this model, we have 3 hubs and a link that's connecting those hubs. And then all of those hubs have some satellites and satellite current views. linked to them, and then the link also has some status satellites and current views for those. So this is automatically generated based on the mappings and loads that you have created on the designer. If we click on one of the entities, you will see some details on the left. So here you can examine the attributes, keys, references, loads, and so on. And if you want to go into the details, you could click here and get to the entity itself to do changes and such. Let's go back. You could also pick one entity and click on the focus entity to get into a focused view that will only show the things related to this entity, like this. Then let's see the data lineage view. Now this is again generated based on the loads and mappings that we've done. And if we, for example, pick a publish table and select focus entity, we will see all the preceding steps that it took to load this fact table. So you have a list of loads and entities starting from the staging tables and the file loads from cloud storage into the data vault entities, and then finally into that load, the fact table that you are examining. To demonstrate how basic data vault modeling is done in Agile Data Engine, let's pick an example and create some data vault entities out of it. So let's go to the staging package, and here we should have a table called taxi zone lookup, which is this one. And this has some attributes. So we have a location ID, and we have some other information related to that ID. So the data set we have behind this is some data of New York taxis and some information related to them. So we will work on this staging table. We will create a hub that contains this location ID, and then we'll create a satellite where we will put this descriptive information about that location ID. So let's jump to the data vault package to first create those entities. Now we will call the hub taxi zone demo, and here you would pick the type of the entity you're creating and the physical type, and then set the schema where it will be created. Now all of this is customizable. You could have your own entity types, and you could define by default which physical types they would have, which schemas they would go to, and so on. But let's create the hub, and then let's create the satellite taxi zone demo. And this will be a satellite. Click create. And now we should have these entities created. And as you notice, there's also a third entity. So this is the current view created automatically based on this satellite. So this will give the latest version of the data over the data vault ID in this satellite, which is basically the ID of the hub. Let's look at one of these. So based on our configuration, ADE will automatically create some attributes. We will have the data vault ID, the load time, run ID, and source. And this is again configurable what types of attributes you would need to have by default. Now we could go into the loads and create an incoming load into this entity from the staging table. But for demonstration purposes, let's jump into the staging package and create an outgoing load from there. So we will find the taxi zone lookup table, go to loads and create an outgoing load. And here we will look for the tables that we have created in Data Vault, so hub taxi zone demo, and the load name is generated automatically based on our selection. Click on that. Now we are jumping to the hub entity, and we actually created a load for it, which is visible in the load tab. And now we get into the entity mapping view. So on the left side, you have the staging table, and on the right side, you have this hub. So we can just jump between these entities like this. Let's first add the location ID, which is the ID that we will be using for the hub. So click here, and we could rename this as a business key or whatever we want to call it. Click map and add, and then we go to the hub side and we configure the same ID to go to the data vault ID. So now we have in our configuration, we have predetermined that the transformation type for DV IDs is hash. So we keep that, click save. And then let's check the other ones. For the DV load time, that's just the current timestamp, which is also pre-selected from the transformation types. And also these, you could add your own transformations in the configuration if you need something that is not there by default. For the run ID, that's also pre-configured as the DV run ID. And for the source, we could pick the name of the staging table. And this would be the custom transformation, and just write the name of the staging table here. Then we could go and add the key, the primary key for the DV ID as well. Actually, this could also be done automatically in the configuration that it would be pre-configured. But let's do it manually for now. And if we go back to the summary, so let's click on the export SQL to see what kind of SQL it will generate based on our mappings. Here you will see the create table statement with all the attributes, their data types, and the comments that will be written to the target database. And under the entity loads SQL, you will see the actual data vault load logic that will be used to insert data into this hub. So all those transformation types that we picked, for example, the hash transformation will be translated into this. And then you have things like the timestamp inserted and so on. And then there's a logic to only insert new values into the hub based on the DV ID. So that's it for the hub. Then let's do the satellite next. So here we also have some pre-configured attributes that have been created. Pretty much the same things that are found in the hub, but we also have the DB data hash column, and this will be used to compare the incoming data to the existing data to see if it already exists, whether it should be inserted or not. And let's first create a reference to the hub. So we have the primary key in the hub, so we will create a foreign key reference to that. And as the parent entity, we will put the hub taxi zone demo. And then we will select which columns it will be referencing. That's it. Then in this case, we could create the load from the satellite, so create an incoming load instead of an outgoing load from the staging table. So here we could give it a name. You could actually write the name of the staging table or however you like to do it. And then click create. And now we add the entity mapping to that staging table. Taxi zone lookup. And now we are again in the mapping view. So on the left side you have the staging, and on the right side you have the satellite that we are creating. Let's first add those additional information fields that we have in the staging. Select them and click map selected by name. So now we created those attributes into the staging table. You can actually see them here listed as the attributes, and the data types have been copied again. Going back to the entity mapping. So next we would map this location ID to the DB ID column. But because we created the reference, we can also use this copy by reference button. Now this would be very useful, especially when we have cases with compound keys that have multiple source attributes that need to be mapped in the correct order and so on. But in this case, it's just one column, so we could also pick it from here. Anyway, let's use the copy by ref, and we have the transformation type pre-selected again. Load time and run ID will be automatically correct like they were with the hub. Then for the DB source, let's pick the name of the staging table. Then we have the data hash that, as said, will be used to compare whether we should insert data or not. And to this column or this hash, we should add all the fields that have been used in this satellite. So you have the option for map all mapped here. So we just click that and it will add everything that we have already mapped to two other columns. And the transformation type is hash again. That's it. Let's go back to summary and look at the SQL just quickly. So again, you have the create table statement, and under the entity loads SQL, you get the logic of inserting data into this satellite. So it looks pretty much the same. You have the data hash column calculated here, and then you have the logic of inserting only changes compared to the current view of this satellite. Let's have a quick look at the automatically created current view as well. So this was created when we created the satellite, and it's just a view that will show you the latest row over the data vault ID of the satellite. Now we left one part out when we created the hub and the satellite load. We didn't pick the schedule for the loads. So if we find, for example, the hub load and look at it, you see that the scheduling is none. So we did this because we have actually already configured a schedule for the staging table. So this staging table is loaded from the cloud storage. So depending on your environment, you'll have either AWS S3 or Azure Blob Storage or even Google Storage behind this. So there's a load file type, and here there is a schedule configured. So if we don't configure any schedules after this, the load will start as configured here, and the following steps will be done after this step has completed in the correct order based on our dependencies and the mappings that we have done. Now let's look at how to implement custom load logics. So when we were creating the hub and the satellite, we used the automatically created load logics that were just created based on our mappings. But often there is the case that you need to actually do some custom work, especially with business vault or publish entities. So looking at this fact table we have here, if we go to the load, we've done the entity mappings here to all the source entities. So there are some satellites and a hub and a link. And on top of that, there are also these load steps configured. So this basically is a logic for truncating and inserting a published entity by first loading it to a temp table and then swapping it with the old version of the existing published table. This is so that the actual table is never empty, and whenever it's accessed by the BI solution or anything that is using it, there's always data for it. So the target database in this demo environment is Snowflake. So actually the first step here is to alter the warehouse size, to increase the size to make the upcoming queries perform better. Then we have a step for dropping the temp table if it exists. Then we create the temp table and copy the grants from the existing published table. Then we have the actual load logic. So there's an insert into the temp table that we just created and all the logic that is related to loading the fact table that we are doing here. Then we have a gatekeeper step, and this is just to check that there is data now after this insert step in the temporary table. And once that is passed, that check, then there is a swap operation which swaps the existing old version of the fact table with the temporary table that we just loaded. And finally, there will be a step to drop the temp table if it exists and to scale the virtual warehouse back down. Now, all of this logic could also be added as a template. So you can configure these templates, and if this is something that repeats quite often that you need to use in multiple cases, you can configure a template for it, and then you could just add it from here and then go customize those steps that are needed to be customized. In the loads, you also have the ability to configure smoke tests for your data. So in this example, we have a satellite that has 2 smoke tests for duplicates. And there are 2 smoke test types, the smoke gray and smoke black. Smoke gray tests will only log the results of the test, but smoke black tests will end the load if an error is detected. As mentioned in this case, the tests are for duplicates. That's quite a common thing to test. For example, in the publish layer, you would test for dimensions or fact tables for duplicates. But you could also have other kinds of tests like testing whether the data is up to date, looking at some timestamp columns, for example. Or you could have tests based on business rules. For example, if you have a fact table for orders, you could test the timestamps in that table. If, for example, the order has been created before it has been delivered, and so on. Let's say that now we are done with the changes and we want to commit them and deploy them to the runtime environments. So let's go to the Data Vault package, and under the commit, you will see the uncommitted changes. And if we minimize that, you will see the history of commits and the commit messages and the details of the changes that have been done previously. Now, under the uncommitted changes, you'll see the hub and the satellite and the current view that we created. To commit these changes, just click Commit Package, and let's give a commit message. Created demo entities, and then just click on Commit, and you're done. Once we're done with the commit, we can jump into the deployment management. Here you'll see a list of packages that have been committed from the designer, and you'll also find the Data Vault package that we just committed. You'll also see the deployments for the different runtime environments. So our package was already automatically deployed into the QA environment. So we can see it here, and if we check the logs, we'll see that it's successfully finished. And looking at the logs, you'll find the create table statements for the satellite and the hub, and the create view statement for the current view for the satellite. So if you'd have any problems with the deployment, you could examine the logs and find your errors here, and then go back to the designer, fix your issues, and redeploy, and then possibly end up with a successful deployment. Now, in our demo case, the promotion and deployment of the package was automatic, but of course all of that is configurable. So quite a common approach is to have automatic promotion and deployment into your development environment, but then you would have to do the promotion and deployment manually to the environments after that. So for example, for your test environments and your production environments. Next, let's look at the runtime environments. So in each runtime environment, you have the dagger, which looks like this. Here you will have a list of DAGs. A DAG comes from directed acyclic graph, and these basically correspond to the schedules that you have configured in the designer. And Dagger orchestrates the loads based on these schedules, and here you can turn the schedules on or off, and either also manually trigger the DAGs if needed. Now let's go to this trip data DAG, which is the one that we have been working on in this demo. And if we look at the graph view, you'll see something similar to the data lineage view that we had in the designer. So here you'll have the whole chain of loads starting from the staging to the data vault and finally to the publish layer. Dagger also logs all the results of the loads that it has orchestrated. So if we go to the tree view, we will see a list of loads, and I've actually recorded this part of the video a few days after we created those satellites and the satellite and the hub, so we can already see some results for the loads that have been run for those. And let's look at, for example, this satellite load. So here you'll see what has happened. There's the insert statement, and it has inserted a number of rows into that satellite. And if you'd have any errors in your loads, you would find the error messages in these logs. On top of that, you can also examine the duration of your loads. So you see some statistics of the past days, and you can also analyze with this kind of Gantt chart how long each of the loads has taken and which of them have been executed in parallel and so on. Each Agile Data Engine environment also comes with a visualization tool, Grafana. And with Grafana, you can tap into all the metadata that has been generated by Agile Data Engine. So, for example, you could create monitors for your loads and add alerts for failed loads. If we look at one of the visuals here, you can see that behind it is just a query into the metadata database. You could also have views for your smoke tests to see how the situation with data quality is at the moment. That concludes our demo. Please head on to our website for more information about Agile Data Engine and for our contact details if you'd like to learn more. Thank you for your time and have a nice day.